Hello, everyone. Happy New Year, and welcome to today's version of Data Raven's data science channel for YouTube. After surviving a very interesting 2020, which some may call an anomaly, today we're going to talk about anomaly detection. And when the business problem that we want to be able to solve is that, let's say you're tracking a metric and there have been some points on there that don't seem to be normal or the norm. They could be considered maybe blips on the screen, and you're trying to figure out, is it an anomaly? In Six Sigma terms, we might call that special cause variation, and the normal here is not related to the normal distribution, just something that doesn't look right when you look at it compared to everything else. And that's really what an anomaly is. It's an outlier, a data point. It doesn't follow the collective common pattern, whatever that happens to be, of the majority of the data and patterns, and it can be separated or distinguished from the rest. And when you think about it, like I said, COVID-19, we've survived different things of different scenarios, and now people are talking about the new normal. But really, before it was the new normal, the COVID probably could be considered an anomaly. And maybe if we had the right metrics and the right tools in place, we would have been able to detect it much earlier, from a data perspective. But really, it's something, an anomaly can have a positive or a negative effect on your business if you can catch it fast enough. And it really could, obviously, it could affect the long-term business strategy. So being able to do anomaly detection will be helpful for any data scientist or data analyst. And today we're going to talk about and show you some different tools to be able to do that. So today we're going to go into an introduction to anomaly detection. We're going to compare it to some other basic statistical things, but we'll be looking at a data set that we artificially create and looking on how we could find anomalies. And then we'll be looking at a real world data set to be able to do that. And when we look at our framework that we reviewed in our very first video, today we're going to be working on, how do we bring in the data and improve the data quality? How do we get a description of what the data is? What are the descriptive statistics? And then we're going to diagnose the data, again, looking for that and those anomalies. And really, we're also trying to understand patterns here, but that's really as far up as we're going to go in this particular instance. We're going to cover some time series anomalies later on in this series. But again, just want to give you a basic understanding and beginning understanding of anomaly detection. So let's go ahead and jump right in. So I have here a Jupyter notebook in Python. Again, we'll be doing this today in Python. This will be up on my GitHub page for the YouTube channel. And again, I've started this through Anaconda, and I've gone ahead and created this notebook. So the first thing we're going to do, as always, is we're going to bring in our different packages. Again, remember, when the star is there, you'll get an hourglass up here, and that will be showing that the system is working. You can hear your hard drive cranking in the background, and when it completes to a number, then you're ready to move to the next step. So what we're going to do is we're going to create a dummy data set for ourselves here, and it's really only going to contain two columns. The first column will be the name of the employees of a fictional organization, and then the second column will be the salaries of those employees with a range of 1,000 to 2,500 monthly. And we use a program called Faker here, which will create that list of names. Again, if you need to install it, you can run this cell. I already have it on here, so I'm not going to do that. So what I'm going to tell Faker is, let's go ahead and create a list of names. I'm telling it specifically, giving it a list command, and I'm giving it I need 100 names. And then I'm going to do a length command, length of the names list, to verify that I actually have it. Again, we're going to use the Faker seed here of 4321, and that's if you want somebody to be able to duplicate your results. So I'll go ahead and I will run this, and it will finish, and it'll tell me, sure enough, I created a list with 100 there. It's the size of, it's 100 lines long. The next thing I'm going to do is I'm going to create my random salaries between 1,000 and 2,500. You can see here I'm using NP, which is, again, is NumPy from an earlier session. I'm going to bring in, I'm going to go through a loop here 100 times, and I'm going to create a random integer between 1,000 and 2,500. And again, I'm going to verify it with a length command, the length of salaries. So I'll go ahead and run that. There we go. Boom, we're done. So now I'm going to combine those two lists into a data frame called salary DF. So you can see I'm going to take that, I'm going to call it person from the names list and salary of the salaries. And then I'm going to print the head. The DF head is the pandas command to print the header or the first 5 rows of that data frame. So there we go. You can see here, again, Jason Brown, 1175. And then you'll notice here, again, even though I tell it the first 5, in the data science notation, both in R and in Python, you'll see it actually numbers them. The first one is 0 through 4. Sometimes you have to remember that if you're looking for a certain record. So now what I'm going to do is I'm going to go in and I'm going to manually change location 16 to 23, and I'm going to change location 65 to 17. So I'm manually going to do that. So I'm deliberately creating lowball entries in this particular data frame. And then I'm going to verify that that actually did happen. And sure enough, there it tells me that Miss Amanda Harris, MD, she's 23, and Joyce Bishop is 17. So let's now talk about anomaly detection. So one way we can do that is with a box plot. Sometimes we call this a box and whisker plot. This is the box, and these are the whiskers. And you can see here that it will show you the minimum value, the first quartile. The median is this dark line, and that goes through the center of the box or somewhere in the box. The third quartile, the maximum, and then any outliers. And we know now, if you remember, this is showing an outlier above the data. But what we're going to do is we're going to create this, and we can pretty much predict that we're going to see those outliers down below because they were very, very low. So when I run this, sure enough, it shows me there's my between 1,000 and 2,500. So it did what it was supposed to do, the random number creation. And if you look closely enough here, you can actually see that there are actually 2 circles there. It's kind of a little oval from the 2 circles being on top of one another. So right away, we could see that when we run this, it could be a keying error. Somebody, instead of typing in 2,300, typed in 23, or it was originally in thousands or hundreds, and somebody put it in there. But again, you can see that the box plot tells us that something's wrong with this data set here, or with these 2 data points. So the other thing that we could do is we could run a histogram, and we'll run a histogram. Again, you can see here we're using the palette here. We're going to say salary in US dollars. The kind is a histogram. We're going to label it salary in US dollars. And when we run that, again, there's our 2 values way down to the left there. So again, you don't know why at this point, and that's not really what we're going to get into today, is the why. We just want to know that sure enough, there's some low values there, some anomalies in our data set. So what we can do is when we go to investigate, we might say, okay, well, what are the minimum and maximum values in my data set? And when I do that, it tells me that, I'm ranging anywhere from $17 to almost $2,500. And you would know, again, as an HR person, I know I may have people lower, but I know that there shouldn't be anybody in this case below $1,000. So what I'm going to introduce you to today is a tool called K-means clustering. It's an algorithm in Python, and that is used to basically group things together. And what we're going to do here is, and you can read more about K-means clustering at this link, but we're going to basically show how this can also detect anomalies. Now, for example, you may want to know a little bit more information, or you might want to get a better view of what this looks like. So the first thing we're going to do here is we're going to take that data frame and we're going to convert it to values. And we're essentially going to create a NumPy array here. And they're basically going to all be, it's going to be numbers, and instead of having the names. And what we'll do here is we'll go ahead and run this, and then we'll bring in from SciPy, we'll bring in this K-means module, and we'll basically tell it that we want to run we want to establish 4 clusters. We're telling it we wanted to group it into 4 clusters. Now there's different things when we get into k-means clusters later on. We'll show how you can select the number of clusters, and sometimes it's an iterative thing. But in this particular case, we're going to go ahead and tell it I want, based on the salary raw data, I want 4 clusters. So we'll go ahead and run that. And you'll see it took a little bit longer because now it has to think and it has to review each piece and compare it to the others. And what we're going to do here now is we're going to go ahead and create that. We're going to go ahead and set it up for plotting. So we're going to create these groups, and we're going to take what we created up here. We're going to create the groups, and then we're just going to do it on a scatter plot. So you can see here I'm telling it to do a scatter plot of the salary raw. I want to arrange those 100 values, and I want to group them by these groups that we calculated up here. And when I do that, it's going to show me again very clearly. I kind of have 3 or 4 ranges of values. I have this something seriously wrong here, or we're really underpaying these people down here, and this is purple, maybe hard to see on the screen. In this dark blue, I have this basically band of salaries between 1,000 and 1,500. I have a yellow between 1,500 and 2,000, and then I have a green between 2,000 and 2,500. Again, this may be, the box plot's only going to show you that there are some outliers. This may group them into different groups, depending again on where they stand. So again, unsupervised method there. But what I want to show you now is, again, a real world example. So there was a lawsuit that was involved with the amount of time children were detained by ICE. And we were asked to analyze that data and see if what was the standard practice. So we're going to go ahead and we're going to do this. And the real challenge here was there was over 500,000, almost 600,000 children that were detained during the time period that we were looking at here. So I'm going to bring it in. I'm going to bring in this CSV file as a data frame, call it DF2. And then we'll take a look at the header again. And you can see here what I have my date in, my date out. I have this app date, which has a lot of non-values in there. I'll have the hours in custody, which is really the thing that we're going to be looking at here. I have an age group. I have a gender, their initial country of citizenship, what border they came in, and sector, what field office they came in from, and then the source. So when I look at this, the DF2 shape tells me the shape of the data frame in terms of columns and rows. So when I do that, this is telling me I have 583,000 rows with 11 columns. And then when I do a DF2 describe, it's going to give me the statistics on the data frame. And if we look up here, we can see that only this hours in custody will give me something because it's the only one that's active. Okay, so what we can see here is that when I did this, it gave me again my count, and it probably is different because it's probably 700 because there's a few that probably don't have any numbers in there. You can see the mean was 65, standard deviation was 81, the minimum was minus 13. So that tells you right there that there's problems with the data set because you can't be somewhere for minus 13 hours. And then this really is start building our box plot here. Our 25 percentile is 31, 75th is 85 with a maximum of 27,000. And when you look at this, a mean of 65, 3.5 days or 2.5 days, and a maximum of 27,000, that really shows you that something's really going on there. So of course, when we run our box plot here, this tells us, there actually is a box and whiskers there. It's just that they're very small. They're compressed because of the scale of all these outliers. So what you can actually do is in Python, you can use this command called show flyers equals false. So if you put true, that's the default, and they just show up there. But when I run this, again, I see that, my median down here is around the average of 65. So they're close to one another. But you can see here that the majority of my data is in here. And I have this huge set of outliers, with the maximum here being 170, about 160, I guess, 165. So something is really wrong there. And let's start taking a look at why that could be. So the first thing we did was we ran it by gender. And when we did that, what we noticed there were really 2 ways of showing gender here. One was F-female, and female for female, and then M dash male and male for male. And we thought that was a little strange. Why, why are it's the same agency, but why is that different? So let's take out those outliers again. Again, we use the show flyers false. We run it, and we see that, yeah, again, we have the variation seems to be more with this female and male. The average is a little lower with this dash, with the dashes, dash female and dash male. But let's take a look at country of original citizenship. So when we did that, it came out that if you look at this, even though there was a large number of countries along the x-axis, there really are only 4 with all these outliers. 1, 2, 3, and 4 down here. So we said, let's take a look at, let's just cut it off at 500 hours and see what the data frame consists of, if just the ones that are over. So we just said here, anywhere that the hours in custody are more than 5 or equal to 500, create a new data frame. So when I do that now, again, I get this over here. And when we started looking at this, we said, wait a minute, we know there's only 2 different sources, and let's maybe investigate the sources. So we created a final data frame called source, where we ran this, and we said, well, when we look at that, 692 of them are this BP, which is the Border Patrol, and the other one is the Office of Field Operations. So they're both within ICE, but they were coming from 2 different sources. So when we box plotted it by source, we said, whoa, something's really different there with this OFO. And again, today we're not going to answer the question, why is that? Why is it different? The last thing we did here was we said, let's go ahead and look at without the outliers. So we took the outliers out of this chart here. And when we did that, we see here again that the variation in the OFO is much more than the BP. So we did a few more things here. We drilled down on this OFO, and then we looked, and we had, again, 95,000 of them were from the OFO. We said, okay, now let's go ahead and convert those, because now we're going to look at it as again, a matrix of numbers. So we convert that, we take out any, and what this will show, for example, is if I don't take out the non-values, when I run this, what I'm going to do is I'm going to get an error, because it tells me I can't contain any infinite or NaNs, which is, no values or blanks. So what I'm going to do up here is I'm going to go ahead and take those out. And it tells me that, sure enough, I do have, do I have any? It's asking a question. So I'm going to go ahead and remove them. And then when I run it again, here it tells me false. And then when I run this, I'll be able to go ahead and get a completion here. Again, I'll come in here and I'll make the groups, and then we'll do our scatter plot. And when we do, what we're going to see here is, again, now in this particular one, I said, okay, go ahead and give me 4 clusters again. I just kept it the same for easiness. And if you look here, what you can actually see is, it's a little hard to see, but if I look at this, there's 4 different colors. I have this gold or yellow color here, which is all the low values. I have a green color here. I have a dark, and then I have a black, which is underneath here, which is like a second layer of hours. And then this blue, dark blue, which is all the outliers. So I could go back, for example, and I could tell it to cluster more. I could go back, for example, and make this, I'll just go ahead and make it an 8. So when I run this and I rerun it, and you'll see what it's taken a little bit longer, because it's having to group more and make more of those different colors. And again, now what I've actually started to see is the outliers have really been broken into really 2 different groups. I have a green, a dark green here, and then I have a dark blue. And again, you can continue to drill down number of layers, but again, I just wanted to show how you could use this particular tool for anomaly detection. So that'll do it for today's video. If you like us, again, please subscribe to the channel and like this video, and we'll see you soon in the next video.